Hello guys, today we are going to complete basic inorganic nomenclature. I'll try my best to explain you in the bestest possible way, but please wait till the end and you'll 100% get something out of this video. Means you'll 100% understand everything. Okay, so basically let's start from the very basic, which is compound. Compound is made up of two parts, which is cationic part and the anionic part. So to name cationic part and anionic part, we will understand the rules, and to name compound, we actually have to understand both the naming of cation and anion. So let's begin from the very first, which is cation. Obviously, we know it's the positive part of the compound, it's the negative part of the compound, and we also know that this is acidic in nature and this is basic in nature. Alright, so basically this was the very basic thing that I wanted to do. Now if you want to name cation, you have to have the knowledge of two things, 2 points, which are basically the first one being element's name. Second one is whether or not they have more than one oxidation state. You have to have the knowledge that whether or not the element has more than one oxidation state. Alright, so basically, for example, if it is cation sodium plus, you can just name it by their name, which is sodium. If the cation is Mg2 plus, you can just name it by their name, which is magnesium. Okay, magnesium. Alright, now for doing the examples, I'm gonna draw a table out of here. So we'll have this table, very nice. Alright, so basically we'll understand the examples with this table. So try to understand that if we have iron, then it can exist in two oxidation states, which is 2 and 3. How to name that? For that I have one trick. This is that trick. Let me just highlight this. It is the trick to actually understand how can we just predict which suffix will be there in the name of that anion. Okay, so if for example smaller oxidation number for a given element, smaller oxidation number, for that basically we have the suffix which is us. So it is smaller, but the number of letter in the suffix is more. So for that analogy, you can just understand that this would be there. Now for larger oxidation number, you have the suffix which is ik, and it has less number of numbers of letters. So basically you can just form the analogy and then complete your names. For example, this would be ferrous, it would be ferric. Similarly for Pb, it can 2 and 4, and it would be accordingly plumbus, it would be plumbic. Similarly, you have Ce, which can exist in 2 and 3 oxidation states, so it is cerous, ceric. Similarly, the last example I'm going to take is copper, so it exists in 2 and 3 oxidation states, so it means it is basically cuprous, cupric. Okay, nice. Now we are done with the naming of cations. Alright, now try to understand. We're going to name, or we'll understand the naming of anions. Anions are of two types. We have non-oxo anions, which do not have oxygen in them. Non-oxo anions. Let me write it again. Non-oxo anions and oxo anions, obviously. Non-oxo anions and oxo anions. Alright, non-oxo anion, for that basically we have to understand two things, that they are derived from covalent hydrides. Okay, they are derived from covalent hydrides. Now these covalent hydride can also include some of the acids, okay, and it can also include some other compounds, so therefore we'll include both of that. For example, in case of acid, the acid would end with suffix. I'm writing here suffix. acid would end with suffix which is ik, but for anion, anion would end with suffix ide. So I think it's clear to you that for acid the suffix will be ik, and for anion the suffix will be ide. So this should be very clear to you. But acid is just the one part of the picture, but other part is other ions also. And what do I mean by other ions? Other ions means like, for example, oxide ion, peroxide ion, superoxide ions. We'll talk about it also. Just wait. Right. Okay, so let me take some examples of acid and anions. Okay, for that let me have the table, and we need just 4 columns, so I'm going to make it 4. Alright, so it is 4. Now let's draw the table here. Okay, and okay, so basically let's see, we can just divide into rows, 2 columns. Alright, so basically we have HCl, HBr, these are acids, and I'm gonna write anions here. So HCl, HBr, HI, HF. What are these acids? These are the acids whose name ends with ik, or I should say these are the acids, these are non-oxo acids, which means they do not have oxygen in them. So these are non-oxo acids. Alright, they're non-oxo acids. So for example, the anion here would be called as chloride ion, the bromide ion, iodide, and simply fluoride. Alright, so basically this is how you can name the anion of the acids which are actually non-oxo acids, or we can say which are covalent hydrides. Alright, there's some more examples except these acids. Alright, so we'll make it 2, and right, and we'll have the columns, for example 3. Okay, so let's make this, and we will cover in this basically some of the examples. So I'm gonna have oxygen, oxide, this is oxide, and this is peroxide. These are some non-oxo anions. Examples. And this is O2 minus, which is superoxide. So basically you understood how from acids, these are acids derived non-oxo anions. But as you can see, these are just non-oxo anions which may be derived from some covalent hydrides. There are some other examples also. For example, P3 minus, right, this is phosphide ion. Then you have Te2 minus, it is telluride. And what all you have to do is that you just have to add ide here and the name of that element. You should start with the name of element and then add ide here, and you'll just continue with the name, you'll make it, right? So I think this is very much clear. So this was all about non-oxo anions. Talking about oxo anions, for anions we had non-oxo anions. Okay, now also we have oxo anions. So for non-oxo anions, we saw that we just have to add ide word to the anion to actually make this complete, right? To actually complete it, we just have to add ide here to name a particular non-oxo anion. For oxo anion, we have to look into 2 things. Okay, for oxo anion, we have to look into 2 things, which means that we have to actually look into 2 things, which are acid. Non-oxo anions, obviously they are derived from some acids, oxyacids. Which type of acids? They are derived from oxyacids. Okay, they are derived from oxyacids. Now if oxyacid name ends with like ic, okay, if oxyacid name ends with ic, then anion would end with a name or would end with the suffix, okay, what 8. And if the acid name ends with, you know, us, then the anion name would end with ite. So this is how you can see, this is the general rule. We'll just cover in detail about oxoanions, how to name it. Each and every point will take 4 points, and we'll just cover it in detail by actually writing all the examples in tabular format, and you'll just understand it beautifully. But here, for the sake of understanding, you have to understand this is acid and this is anion, right? So you can see this as oxoanions dependence on the acid. Basically, the name of anion depends on the which acid or what is the name of the oxy acid from which it is derived. So therefore we have to understand the naming of oxy acids for the sake of understanding the naming of oxoanions. So I think that you got this, that why or what is the purpose behind understanding the name of oxy acids. So let's see. Okay, the first point, element. First of all, you have to understand what is element here. Element, basically oxy acid we are talking about, so it would have hydrogen also, it would have oxygen because of oxy acids. Being oxy acid, it would have oxygen and one element that would define its property. So I am calling the element whatever x or y or whatever xyz element is there, except hydrogen or oxygen. Except hydrogen, oxygen, whatever element is there, we'll just call it element. Now first point, which is general thing. First point, we'll see that element, if element has only one oxidation state, OS is for oxidation state. If element has only one oxidation state, how we'll name it? Okay, first of all you have to understand one thing, that in this case acid, oh I'm sorry, in this case acid, oh god, in this case acid name ends with suffix ek only, and the anion would end with the suffix 8. So what we'll do, we'll write the name of acid, then the name of acid, formula of acid, name of acid, formula of anion, name of anion. And how can we identify? So we can identify it by just oxidation number. So oxidation number would be the criteria to actually identify it. So we'll just have to see that it has only one oxidation number, so it would be the category 1, right? So I'm calling it category 1. Alright, so this is category 1. Alright, so let's form the table. So basically in total we actually need 2 to 4 and 1 5 columns. So we need 5 columns, guys. Right, and we're gonna do some examples, right? So how many examples are we gonna do in this? We're gonna do 3 examples. So let's see whether it was 3 or not. Yes, it is 3. Alright, so let's draw the table here. I think it's alright. Okay. Now let's see how can we do this, right? So basically we have to identify the oxidation number, we have to see acid name, acid, then for anion, and then for anion name and everything we'll do in one column only, and the last column we'll just keep it for anion name. Okay, so So let's begin with oxidation number. Let's see what is the formula for the acid we're taking up. Bromic acid, boric acid, sorry. So this is H3BO3. Boric acid is 6 minus 3, which is 3, plus 3 oxidation state. Only one oxidation state exists for boric acid, is this one. Obviously, why we called it boric acid, why not borous or borium, whatever acid? Because of the fact that it has only one oxidation state, so boric acid. And then anion, here anion will take up is basically borate. Why? Because it ends with ic. Okay, borate, anion. Then we have anion name, so it was borate anion. And anion formula, okay, so anion formula would be BO3, and whatever the number of charge hydrogen would have, same number of charge would the anion would have, but it would be negative sign, so it would be 3 minus. Similarly, we have H2CO3, which is obviously carbonic acid. Why? Because it has only one 6 minus 2, which is plus 4 oxidation state, only one oxidation state. It would be carbonate ion. Why carbonate ion? Because it ends with ic. And similarly, we have CO3 2 minus. Then we have H4SiO4 silicic acid. 8 minus 4 is plus 4. Oh god, plus 4 oxidation state, then it will be silicic acid. Okay, now silicic acid would have the oxidation state which is silicate. I mean the anion name would be silicate because it ends with silicic acid. And SiO4 4 minus would be the name, would be the formula. Alright, so we have actually completed the first point example के साथ. Now basically let's try to complete the second point. Second point is that when element has two oxidation state. In a similar manner, if we have to do for acid and ions, what will be the name? The suffix of acid and anion, and then we'll deal the example of it. Okay. So basically we have acid and anion and oxidation state. So basically if it has larger oxidation state, for example, if it has larger oxidation state, then in that case, okay, if it has larger oxidation state, if it has larger oxidation state, then in that case we have to write that in case of larger oxidation state we have to write IC acid. Okay, suffix will be IC, and in this case will be 8. Similarly for the smaller ones, smaller oxidation state, the acid and anion, so acid would end with us and anion would end with ite. So let's do the example. So again we'll have the same number of columns and rows, but I think we'll do 2 of the examples only, so let's reduce the number of rows here to 2. Okay, so let's form the table right over here. Okay, then just shift it. Oh god, can we just shift this table? No, we can't. It's okay. So basically we have to do the examples. Alright, so oxidation number, acid only, anion and anion only. So basically for the larger ones and the smaller ones will do. So how can we identify? See, mathematically also you can calculate what will be the oxidation state, but if the number of oxygen is more, oxidation state will be more, because whole structure is the same. Like for example, I'm taking up H2SO4 here and H2SO3 here. Same is the structure, right? H2S, but the number of oxygen are different. So on the basis of that only you can identify that what will be the oxidation number. So it has more number of oxygen, larger will be the oxidation state, less number of oxygen, smaller will be the oxidation state. Simple. Now talking about what will be the name of this acid, because it has larger oxidation state, the name of acid would end with ic. What will be the starting of the name? Starting name will be the name of the element only, so it will be sulfuric acid, and accordingly it would have okay, tell me the anion. So anion would be, because it ends with ic, so it will be sulfate anion or sulfate ion, and obviously the formula will be SO4 plus 2 charge. Yeah, this has plus 2 charge, so it will have minus 2 charge, 2 minus, and then you have sulfurous acid, and accordingly you can say that the anion would be sulfite ion, right? And accordingly it would have SO3 2 minus. All right, so this was the example we did. Coming to the third point, that if element 3 oxidation state, what will we do if element has 3 oxidation states? So we'll see acid and anion. Okay, let me write in this way so that it will take less space. Okay, so oxidation state, acid and anion. If it is the largest, then middle one oxidation state and the lowest oxidation state. Okay, the largest oxidation state. Okay, the largest oxidation state would have the suffix in its name of acid as ic. Then the middle one would have us, and the last one would have hypoos. Hypo would be the prefix and us would be the suffix. Similarly, and this would be ate only, it would be ite only, and the last one would be hypoite. Hypo will be the prefix and the suffix would be ite. So basically, similarly, we are going to deal with same number of columns, but the rows here will be different because we are going to deal with 3 number of examples. Alright, so okay. Alright, so basically we are going to write the examples. So here will be the oxidation state. Here will be the oxidation state. This will be the acid column, anion column, and then anion column. Let's start with the highest oxidation state. Then we'll take the middle one, and then we'll take the lowest oxidation state. So name of acid, see the name of acid here will be because we have to take 3 examples, so name of acid would be H3PO4, H3PO2, 3, and then H3PO2. So name of acid, how we'll name it? Highest oxidation state, so it will end with ic, so it will be phosphoric acid. So the anion here would end with phosphate ion. Similarly, if it is middle one, so it will end with phosphorus acid, and an ion would be force fight ion. Similarly, this would be hypo phosphorus acid, and an ion would be hypo, because us is there, so it would be phosphite only, right? Ion. Alright, and the last one column will fill a most important thing. To understand that, first we have to actually look into the structures. So basically the structure of H3PO4, H3PO2, 3, and H3PO2. So basically, it will be P double bond O, single bond OH, OH, and OH. Similarly, this will be P double bond O, this will be OH, OH, H, P double bond O, OH, H, H. Alright, so try to understand here that because we have three hydrogens attached to this and this and this, right? Because we have three hydrogens attached to this and this and this, therefore the basicity of this will be 3. Similarly, the basicity in this case will be 2 because two hydrogens are attached to it, oxygen, and the basicity here will be 1 because one hydrogen is attached to it. So for that reason only, in this case the basicity is basically 3. This case it's 2, this case it's 1. Because of that, only one hydrogen can be removed in the reaction. In this case, only two hydrogen can be removed in this case and this case. So these are the cases that you have to think and remember. But what is the trick to understand this? See, first of all, in double bond, one oxygen would be engaged. One oxygen would be engaged in this double bond. Rest of the oxygen from this, one oxygen is engaged, 3 oxygen is left. Rest of the oxygen will be attached to hydrogen, right? Because there are 3 hydrogen always. Now one oxygen would be engaged in this case, rest 2 oxygen is left, so rest of the 2 oxygen would be attached to hydrogen, and one hydrogen will be left. Similarly, one oxygen would be engaged here also in hydrogen in double bonding formation, and one oxygen would be engaged in hydrogen, attaching hydrogen. So it depends on the number of oxygen that are free. So we can actually understand by that formula that the basicity would be the number of oxygens minus 1. Okay, number of oxygen minus 1 because one oxygen would be engaged in double bond. So I think you understood this point, and you can understand the trick as well. So let's see what would be the anion formed here. So here the anion would be no, not H, PO4 3 minus, because 3 is there. Okay, now it would be H, PO3 2 minus. Why? Tell me why. Because of the fact that this will be broken into H plus, and baki it will be broken into H, PO3 minus 2 minus. Why? Because the rest of it will have 2 plus. Okay, why? Because there are 3 hydrogens, so 2 hydrogen is there and 1 hydrogen there, so 2 plus is there and 2 minus there, so therefore 2 minus. Because only 2 hydrogens are removed, basicity is 2, so 2 hydrogen removed. Why it has 2 plus? It does not have 2 plus. Okay, hydrogen does not have 2 plus charge. It's just that there are 2 hydrogens that have plus charge each, therefore I say that it has 2 plus charge. But it's wrong to say hydrogen has 2 plus charge. It's just that hydrogen has plus charge, or 2 of them has plus charge, and therefore we get this ion. Now similarly we can see and get this ion, right? Because it will be broken into 2 things, and obviously that would be, let me draw here. Oh shit, no, I cannot draw here. Let me draw with this one. So it would be broken into 2 things, and that would be hydrogen. One hydrogen will be released, and basically other would be created into anion. It would have minus charge each anion. Okay, so basically I think you understood this third point. Let's move on to the fourth point, and that's the most important point. Okay, so the fourth point says that if the element has four oxidation states, then what we would do. So oxidation state, suffix that we would add with acid, and the suffix that we would add with anion. So basically the largest one, the next lower, okay, next lower, and the lowest. So basically the largest one would have per in the prefix, and then we would add ik to it in the last, or the suffix. So, and then anion would be per only, prefix will be the same, and it would end with 8. Similarly, the next lower, for that we have ik and simply 8, and for this we have us, and this would end with simply ite. Then finally we have hypo is the prefix, and then we have us, and simply it is hypo prefix, and the last it has ite. Alright, so this is the formula and everything, or you can say the rules. Now we're going to deal with 4 examples. So we'll have 4 columns, right? We'll have 4 columns. So let's see. Right, so 4 rows, sorry. Alright, so let's just form these rows and everything. Okay. So these are the rows. Now let's get started. Let's see the example and understand beautifully all the things nicely. So this would be basically oxidation state for acid, this also for acid column, and this is anion, and this also for anion. So basically the highest one, the next lower, and then we have the lowest. So basically for acid, you have to understand the example we are taking here is HClO4, HClO3, HClO2, and HClO. Then basically what would be the name of it, right? Nice. What would be the name of it? So you just convert this color into yellow. So basically what would be the name of this? It would be um, perchloric acid, right? Perchloric acid, and similarly the anion would be perchlorate ion, and the formula would be obviously ClO4 minus, simply this will be not per actually, simply chloric acid, and this would be simply chlorate, oh god, chlorate ion, it would be ClO3 minus. Then we have chlorous acid. Okay, so this will be chlorous acid, and hence it will be chlorite ion simply, and then it would be ClO2 minus, and simply it will be hypochlorous hypochlorous acid, and hence it will be hypochlorite ion, and it would be ClO minus. Nice. So we have done all the examples and everything to understand it perfectly well. So we have completed the whole oxy acid formula or oxy acid rules, and how to name oxo anions and everything. Now let's come to one and the most important thing, which is pyroacid. How to actually understand the naming of pyroacid. See, pyroacid is just formed when we remove one H2O molecule. When one water molecule, we remove one water molecule from what? From two molecules of acid. Yes. From two molecules of acid, we have to remove one molecule of water, and then we get pyroacid. So basically in that scenario, let me give you some examples and we'll try to understand it very nicely. Alright, so let's start with sulfuric acid, H2SO4, right? So 2 molecule of it, removing 1 molecule of water, you will have multiplying by 2, 4, 2, 8. So it will be H2S2O7. So this will be known as pyrosulfuric acid. Name will be same, but pyro will be added to obviously differentiate it. And the anion that would be formed from this, that would be S2O7 2 minus, and this anion will be called as pyrosulfate anion. See, this had the capability and capacity to actually give out 2H plus ions. Therefore, this pyro acid was formed. But if it does not have the capacity or capability to actually give out those two hydrogen ions, then that pyro acid won't be formed, right? Okay, so the next example that I can take here is silicic acid. Removing H2O, so it will be 8 Si2O8, and that comes out to be H6 Si2O7, and then it comes out to be, okay, so what is the name of this? So it will be simply pyrosilicic acid, pyrosilicic acid. And what will be the anion that will be formed? So Si2O7 6 minus, Si2O7 6 minus, right? So it will be, the anion will be called as pyrosilicate ion, right? And ion will be called as pyrosilicate ion, right? Now one more example we'll take. Okay, now important examples are coming. Okay, so I am writing important with the help of these. Okay, this is how we make it so different. So basically, so what is that important point which I am highlighting here? The important point is that we are going to deal with H3PO4 family and all those phosphoric and phosphorus and hypophosphorus acids and everything. So twice of it, removing one water, it will be H6P2O8, simply H6, okay? Then it will be H6P2O8, it will be H4P2O6. It had the basicity, it has the basicity of 2, sorry, of 3. It has the basicity of 3, which is basically equal to 4 minus 1, and that would become 3. So basically it has a basicity of 3 because of that this was formed, right? Because of that it can release 2 water. Okay, so therefore this pyro acid was formed. So pyrophosphoric acid, I made phosphoric acid, and the ion that could be formed from this is pyrophosphate. Alright, coming to the next acid, which is second one. This was the first one. Second is H3 PO3. Removing one water we get, okay, this is 6 to 8, okay, 6 to 6, right? And this will be it has basicity of 3 minus 1 comes out to be 2. It has basicity of 2, so therefore it can release 2H. Okay, so it will be H6. So H6 will basically be H4P2O6. Alright, H4P2O6. H4P2O6 or O5, sorry. Right, so it will be basically pyrophos phosphorus phosphorus acid, pyrophosphorus acid. It will be pyrophosphorus acid. But one thing that you have to remember, that the anion here will be formed. See, let me write the actual you can say the formula of anion. So it will be P2O6 4 minus, P2O6 4 minus in this scenario, and we have actually formed it here also, here also. So I showed you here it would be P2O6 4 minus, but here it would be H, because the basicity is just 2, so it can remove only 2 hydrogen. 2 of the hydrogen will be attached to it only, and because 2 hydrogen is removed, so 2H plus, that means total positive charge is 2 plus, so it will be 2 minus. So this will be the actual pyrophosphite ion. Alright, pyrophosphite ion. Now let's see one more beautiful thing. Okay, so that is H2PO, sorry, not H2, H3PO2. So two of the molecules, let's try to remove H2. Oh. Now we saw the basicity of this is equals to 2 minus 1, that's 1. How can it remove two hydrogens? How can it remove two hydrogens if the basicity is only 1? So hence it cannot not formed. Okay, it cannot be formed. Right, so we'll write that this is wrong. It cannot be formed. So pyroacid cannot be formed. Can't formed. Can't be formed. Pyroacid can't be formed because of the fact that the basicity of this, we can say this what phosphorus acid, the basicity is 1, and therefore it cannot form pyroacid. Right, because of the fact basicity is 1. I think you understood all these things. So very beautifully you understand all those things. Let's talk about another type of acid, which is meta acids. Alright, so simple, it's like pyroacids, but you have to understand that you have to remove H2O not from 2 but from one molecule. One molecule of acid you have to remove H2O. So let's take example. For example, we have H3PO4 and H3PO2 3 and H3PO2. So can it remove two hydrogens? Yes, it can. Can it remove two hydrogens? Yes, it can. It cannot. So it will not form metacids. So who will form metacid? These compounds. So let's see how they'll form metacid. Alright, so basically let's see, minus H2O, minus H2O. So in this case this will be basically H2, okay, 2 should be removed, HPO4, okay, HPO3, right? Two hydrogens are removed from this and one oxygen is removed, so it will be this. Then it will be HP, and two hydrogens are removed from this and one is removed from this, so it will become 2. So basically this is what we can call this. This can be said that we can call this as metaphosphoric acid, and the anion that it can form is simply PO3 minus, so it will be metaphosphate ion. Alright, you should be actually very much careful while actually writing the anion for this, because I'm telling you, you should be very much careful, because these sometimes you don't know how much basicity is there, or you know it but you kind of forget it, and therefore you tend to do mistake. So therefore I don't want to do mistake, and therefore I'm saying this, that you should actually be focused here. So it would be a metaphosphoric phosphoric, right? And this is basically this is the middle one, right? And therefore it will be phosphorus. And the iron, since the basicity is actually, you know, I guess this cannot be formed because of the fact that the basicity here, because of the fact that basicity here is not matching it, because the basicity of this one is 2. However, okay, there also we had removed, so basicity is 2, so we can, there is possibility to remove 2 of them, right? So this is wrong, this would be formed. There's possibility to remove 2 of them, right? But we can remove one also, like for example here there was possibility to remove 3 hydrogens, but we remove only one. So like uh, it can be formed, so PO2 minus, and it will be metaphosphide ion. Alright, so I think I've covered it everything. Let's do some more examples to clear this meta acids. So let's have some more examples, like for example H3BO3. H3BO3, removing one hydrogen, we get HBO2, right? And this will be obviously metaboric acid, and the anion that could be formed from this is called BO2 minus, and that would be borate, metaborate ion, metaborate ion. And that, and finally H4SiO4, if we try to form remove this, it will be H2SiO3, and it will be called as metasilicic acid. And then finally the ion that will be formed is SiO3 2 minus, and it will be called as silicate ion. Okay, so we are done. Let's now do some questions. Okay, now we are going to do some questions. Let's do it. Are you ready? Yes, we should be ready because we have done each and everything, and I'll tell you some more points in the end, so be ready. So let's do some questions. So we'll do some questions from random things. Okay, so first question is basically sodium. Tell me what's the formula for sodium pyrophosphate. Okay, so what is the sodium pyrophosphate? First of all, you have to understand pyrophosphate, right? So pyrophosphate is formed from pyrophosphoric acid. Pyrophosphoric acid H3PO4. H3PO4 forms basically the pyrophosphate. So basically you have to multiply by 2, remove one of the hydrogen, multiplying by 2 gives you H6P2O8, and then removing 2 hydrogen will be H4P2O7, and then this will be the phosphate ion. So this was the phosphate ion. You are just concerned with this one, so keeping it here, and oh god, keeping it here, erasing this one, and erasing the rest of the part because this is not the thing that we want. Now keeping this one here. Alright, now we have Na plus. So Na plus means Na, sodium. So this means the valency of this is 1 and the valency of this is 4. Let's erase basically that it has charge 4 because we have written valencies 4. Now crisscross Na4 P2O7, right? Na4 P2O7, we are correct, this is correct. Now let's do the second question. Let me give you a more hard one. So it will be strontium pyrosilicate. Now how pyrosilicate is formed? Look at this. How pyrosilicate is formed? Basically we know pyrosilicate is formed from silicic acid, which is this one, right? So twice of it, removing water, twice of it will be H8 Si2O8, and then you just have to remove water, so it will be H6 Si2O7, and the iron would be Si2O7 Si2O7 6 minus, and very nicely you can say Si2O7 6 minus, right? And then you also have strontium. So the only thing which we needed was this one, so we'll take it with us. We'll take it with us, right? Okay. Now, and another thing was strontium. So we know that strontium, and one more thing, let me actually erase 6 from here, and valency is 6 here, strontium valency is 2 there, and then crisscross, you can cancel this, it will become Sr3, strontium 3, and Si2O7, and this is the correct answer. Yay! Now also some more examples, some more questions, which is zinc azide. I think I told you that azide was important, that was N3 minus azide. Alright, so N3 minus azide. So it's important to understand this. Alright, so basically the zinc azide is N3, and it would be 2 and be 1 crisscross, that would be zinc N3 whole twice. Like this, correct? Okay, let me take some more examples, some more questions actually. Okay, one more question. Let me ask you one more question. Zinc borate. Okay. Form zinc metaborate. Sorry. Zinc metaborate. Okay, so Zn, so it is clear that is true. But borate, metaborate is formed by boric acid. So boric acid basically means, what is boric acid? H3BO3, right? Boric acid was H3BO3 if I'm not sure, or if I'm sure. Yes, it was. Boric acid is H3BO3. Now H3BO3, we have to form meta form. So removing one water from it, we'll just get, HBO2. Okay, so basically we have to form meta form. So anion will be BO2 minus. So BO2 minus will be the anion. That is what we need. And then zinc BO2 minus 1, or we can say just 1 and 1 crisscross, will get ZnBO2. Okay, it has 2 valency, sorry, and then it will be 2. This is correct. Alright, one more example to actually confirm whether you have actually understood it or not. That is aluminium metaphosphate. Aluminium metaphosphate. How phosphate is formed? Phosphoric acid. Phosphoric acid H3PO. Okay. H3PO4, and because it is meta, so just subtract H2O, so HPO3. So it will be PO3 minus, and PO3 minus will be the metaphosphate. So this is what we need. So aluminium 3 PO3 minus 1, so crisscross, and you'll have this one, which is basically AlPO3 whole thrice. Right, one more. Basically the next question is that aluminium metasilicate. Metasilicate means silicic acid H2Si H4SiO4, and removing water from it, you get H2SiO3, and it will be SiO3 2 minus, adding the last page, I guess, AlSiO3 2 minus, and it was 3, so crisscross, and it will be Al2SiO3 whole thrice. Al2SiO3 whole thrice. Yes, it is correct. Okay, guys, one last thing and the tip point. I have to tell you so many tip points also, so be ready. Okay, so the first tip point, that is um actually, guys, ALOH whole thrice can also form meta acid. It is hydroxide, but it can form meta acid, and that is basically also called, sometimes it is also called, and the meta acid would be ALOOH, like this, something like this. I'll tell you how it is formed by just removing H2. Okay, so if two of them are removed, then only one H will be left, and three of out of the three, two are removed, the two is left. So basically this is sometimes written like this, or sometimes written like this also, right? This or this, and both of them are basically called meta aluminate. Obviously this is the word, but also you can also write this as or basically you can also write this as um, aluminium oxide hydroxide, aluminium oxy hydroxide, something like this, aluminium oxy hydroxide. Okay, so basically this was the extra point I want to tell you. Alright, one more thing, that there is basically something called polysulfide ion. Polysulfide ion basically SN2 minus, like S1 2 minus, or S2 2 minus, S3 2 minus. So it is called basically sulfide ion, simply sulfide ion. This is called disulfide. Like for example, H2S. So it is basically H and okay, let me remove it. HNS, so H is 1 and this is 2, and H2S. Basically, you know what? This is disulfide, but um, when you write this in molecular format, then this is what you write. But whenever you are doing a chemical bonding like this, then you try to write this only, because it does not have this, right? I'll share the ideas in comment section also about this, but you try to learn here that for the purpose of examination and everything, that this is called sulfide, this is called disulfide, and this is called trisulfide. Right, and one more thing, the last one, which is CrO4 2 minus. CrO4 2 minus is basically called chromate ion. It is called chromate ion, and it is derived from obviously H2CrO4. This will be also chromic acid, because it's chromate, so it will be chromic acid. Alright, and Cr2O7 2 minus, dichromate. This is called dichromate, and dichromate ion will be derived from H2Cr2O7. H2Cr2O7, it's very famous dichromate acid, dichromate acid. Then one more, we have MnO4 2 minus, derived from H2MnO4 to, okay, H2SO, H2MnO4, H2MnO4. This is basically the acid, and that acid is what? Manganic acid. This is basically manganate ion. This is manganic acid. And the last one, which is basically MnO4 minus, simply that will be permanganic ion, and simply it will be permanganate ion, permanganate ion, and really permanganic acid. Okay, It is derived from HMnO4, that is permanganic acid. Alright, two more examples, please bear with me because I am also putting my efforts. See, um, Xe XeO64 minus is basically per hexanate ion, okay, per hexanate ion, and this is derived from obviously H4XeO6 per hexanate acid basically. And similarly XeO4 2 minus is basically xenate ion, okay, and it is derived from H2 ZeO4, which is obviously xenic acid. So let me just add the last page to actually bid you bye, guys. Okay, so thank you so much for watching till the end, and bye. Thank you so much for watching till the end. Thank you, guys.